Welcome to Bitunet Code channel, guys. In today's session, we'll see the basics of OSPF as per CCNP module, right? So you can see that the IP address configuration will be as usual as we have been using in our previous videos, like IP address between R1 and R2 will be 12.1.1, R2 and R3 will be 23.1.1, between 3 and 4 will be 34.1.1, and between 4 and 5 will be 45.1.1. And in OSPF, the we also need to configure router ID, because OSPF doesn't work without router ID. So we will give router ID manually to every router, and OSPF process is locally significant. So we can use different OSPF process ID on every router. Okay, and the main requirement of OSPF is area. OSPF, we divide OSPF into multiple domains called areas for the easy management of a network. So we keep one area as area 0. Okay, that is called the backbone area of the domain, right? And every other area should be connected to area 0 to exchange the routes in the entire OSPF domain. So in our lab scenario, we'll be dividing our OSPF domain into three areas. Towards left hand side, we'll have area 1, and in middle we'll keep area 0, and towards right hand side we'll keep area 2. Okay, so for easy identification, let me note down the IP addresses. Here will be 12.1.1.0/24. Control C, and let's write here. Here will be 23. Okay, and here we'll be using 3 and 4, 34. Right, and here we'll have IP address scheme as 45. Now let's start the routers and take the console session. Router 1, router 2, router 3, router 4. IP addresses should already be configured. If they are not, we will do that quickly, right? So we have a console session on all the routers. Let's see if we have IP addresses configured. Show IP int brief exclude unassigned. IP addresses are already configured. Uh, Show IP protocols. Let's see if any protocol is running. No protocol is running. Let's go on R2. Show IP int brief. So on R2 we have 12.1.1.2 and 23.1.1.2. IP addresses already seem to be configured. I have configured loopback IPs also, but it's okay. We'll configure router ID manually, right? Actually, the router ID, if not manually configured, will be the highest loopback ID of the network. If loopback ID is also not configured, then router ID that will be picked by the OSPF will be the physical interface highest in IP address. Let's go to R3, show IP int brief exclude unassigned. Okay, IP addresses are already configured. Show IP protocols. No protocol is running. Show IP protocols. No protocol is running on R3. Show IP int brief. IP address is configured. No protocol is running on RI4. Show IP int brief. Okay, here I have five loopback IDs configured on R5 and show IP protocols. Okay, here OSPF is already running. So let's do one thing. No, we just have to click on no. Right now, OSPF should be deleted. Do show IP protocols. Okay, now no OSPF process is running on any router. We will start everything from the scratch except the configuration of IP addresses. Now, first of all, let's go to R1 and go to config terminal router OSPF 1. Okay, router OSPF 1. Let's see what commands we have available in if we go into router OSPF interface. Let me make it a little bigger. Okay, so here we have area auto. The first command that we can use to configure OSPF will be the network, right? Okay, this neighbor command we can use to statically configure any neighbor, but right now we'll be using network command, enable routing on an IP network. So before that we will use a router ID, this command, right? Router ID for this process, router ID OSPF router ID in IP address format. So we will use 1.1.1.1. Okay, network will be 12.1.1.0 and OSPF wildcard base 0.0.0.255. Okay, after that we have to tell which area this R1 should fall in. Okay, we will keep it in. We can use in decimal value or we can use in IP address format. So for now, let's use a decimal value 1. Okay, we are putting R1 F0 interface in area 1. Exit. Show IP OSPF neighbor. Right now there is a no neighbor because we haven't configured OSPF on R2. Show IP protocols. Now here we can see that OSPF process 1 is running, router ID is 1.1.1, number of areas in this router is 1, only one area, no stub or NSSA configured, maximum paths by default it takes 4 maximum paths through which it can do equal cost load balancing, and it is routing for networks 12.1.1.0 and wildcard mask is 0.0.0.255, area is 1. Okay, reference bandwidth it is using is 100 Mbps because we have fast Ethernet connection. And a default AD value for OSPF is 110. Okay, we can change that with the help of distance command. Now let's write it down and go to R2 config terminal OSPF process uh, 2. This process ID is locally significant, so we can keep it different for every router. So now we want that OSPF process should run on the two interfaces. One interface will be 12.1.1.0, okay, 0.0.0.255 wildcard mask, area 1, right? So now this side of router should be in area 1. Enter. Okay, another we got the message that full loading done, a neighborship created. So another interface on which we want to run OSPF will be the this 23 network. So let's make it 23. dot 1 dot 1, but this will be in area 0, right? Area 0. Let's give it a router ID 2.2.2.2. Okay, because we before configuring OSPF on networks, we did not give a router ID, and we gave router ID after configuring the networks, after configuring OSPF on networks, right? So it is prompting us to clear IP OSPF process. So we can do that without any problem. So and clear IP OSPF process reset, yes. Okay, show IP. We got the message that neighbor down, interface down, detached, and it will create the neighborship again. OSPF neighbor. Okay, neighborship again created. Show IP. We can see that it's in a two-way. It is in process of synchronizing neighborship. Okay, show IP protocols. Here we see that pro ISPF process 2 is running, router ID 2, and here we had router ID 1, and it is routing for two areas 12.1.1.0 in area 1 and 23.1.0 in area 0. Okay, now full loading is done. Show IP OSPF database. Let's see this also. So in database we see the different kinds of LSAs, right? So first of all we have a router LSA. A router LSA will be uh, mm, sent by every router in the domain. Okay. So router then LSA 2 will be the network LSA that will be uh, uh, sent for, that will be the summary of networks. And here we have LSA 1 for area 1. This is a router LSA for area 0, router LSA for area 1, network LSA for area 0, network LSA for area 1. Okay, and this is the summary LSA, because this R2 is also acting as a area border router, so it will also create the summary LSA, right? So this summary LSA is the LSA 3, and whenever we configure OSPF on fast Ethernet, we also see DR and BDR election. So LSA2 is sent by DR. So let me show you one more command. Show IP interface F00/0 detail. Show IP show IP OSPF interface F0/0. Here we see the configuration of interface F0/0. We get a lot of important information. Here we see that network type is broadcast, right? Because fast Ethernet connection is a broadcast kind of network. So it elected the 2.2 network, and this R2 is chosen as a BDR, backup designated router. Okay, designated router is 1.1.1. Interface address is 12.1.1 of DR. Backup designated router is 2.2.2 and its interface address is 12.1.2. And the timer intervals that are being used by OSPF, just like EIGRP, are hello timer and hold timer, as compared to hold timer is just like a dead timer, right? Here whole timer is 10 second and that timer is 4 times of hello timer, that is 40 second. And after that, this is the information, and if we want we can also change this hello and a dead timer interval. Okay, so but for now let's complete the OSPF configuration on all the routers. Let's go to R3 config T router OSPF 3 router ID 3.3.3.3. Okay, now here all the interfaces of R3 are in area 0. So what we will do, we will use 0.0.0 area 0. Okay, we have given the shortcut command to use all the put all the networks in area 0. So this command should put all the networks like 23 network and 34 network in area 0. Here we got the message that loading full done, and show IP protocols, and here we see that OSPF 3 is running now. Show IP OSPF neighbor. So neighborship created towards left hand side with R2. Show IP OSPF database. Just like topology in EIGRP, database command shows the topology table or a database table. So here we see a router LSA for sent by R2 and R3, and network LSA sent by DR. The DR here in this network, DR is 2 because we initiated OSPF on R2 before R3, so DR R2 has made itself DR. And summary LSA is to 2.2.2 because ABR is R2, so summary LSAs are sent by ABRs. Now let's write it. Now let's go to R4. On R4 we have interfaces in different areas. One is 34 and one is 45. Config T router OSPF 4 router ID 4.4.4.4, and one interface will put in area 0, right? So that will be 34.1.1. Network 34.1.1.0 0.0.0.255 area 0, and other interface is 45, that is in area 2, right? This 45 is in area 2. We can see that we got the message of full loading done towards the left hand side, and show IP OSPF neighborship created full DR, and this time DR is 3 because OSPF was already running, so 3 declared itself as a designated router. Let's write it down and now go on R5. Router OSPF 5 router ID 5.5.5.5. We can use a shortcut command to put all its interfaces in area 0. 0.0.0.0 in area 2, right? R5 is in area 2. Hit enter and write full loading done. Show IP OSPF neighbor. show IP OSPF database. So now we should have all the then connectivity, show IP route. Here we can see that we got the messages that we are getting inter-area routes also with the help of OSPF, right? So OIA stands for inter-area. Here is the full form of codes that are mentioned here. Here is the OSPF inter-area, right? Now from here we should be able to ping R1. Let's try that. Ping 12.1.1.1. Okay, and we are able to ping. So we have 100% connectivity. Let's try to ping from here. Ping. We'll try to ping 45. 45.1.1.1. It seems 45.1 40 its IP address is 45.4 and this should be 45.5. Okay, so we use a wrong IP address. IP address we are using 45.1.4 and 1.5. Okay, so we have end-to-end connectivity. There is one more command, show IP interface, show IP OSPF interface brief. Let's see what information we get. From here we can see that what interface any area is in and its IP address and cost of that interface and the state. Right, so here we see that R1 is a DR designated router. Let's run same command on R2. Okay, R2 is connected to two networks and towards one hand side it is a DR and towards other side it is BDR. So it is BDR for this 12 network and it is DR for this 23 network. And the cost it is using is 10 because by default cost of broadcast network type is 10. Right, let's use same command on, oh I'm sorry. So here also we see that process ID, we can see OSPF process ID also. On R1 we are using OSPF process ID 1, on R2 we are using 2, on R3 we are using process ID 3, and on R3 we had given 0 shortcut command, right, to configure this. So that's why it has included loopback also on all its OSPF processes. So now loopback is also working, and if we ping this loopback IP from any other router, we will be able to reach this loopback. So uh, in 23 network, this is BDR, and in 34 network, R3 is DR. Let's use same commands on R4 also. So in R4, this then these network also DR BDR election has done. We have process ID, area, cost, and state. Okay, and let's use on R5 also. Okay, on R5 we have only one interface, so that's why uh, this is BDR, and other loopback IPs are also included in OSPF process, because here also we use zero shortcut command to include all the networks in OSPF process, right? Area 2. Now let's try changing some parameters. Go to config interface fast 0/0. Okay, let's see what options we have available here. that we can configure for OSPF, right? So IP OSPF, with the help of IP OSPF, from here we can configure hello time and dead interval. These are the two important timers that are used by OSPF. So if I change hello interval, that is by default 10 seconds. A dead interval will also change automatically, and because this is the requirement of OSPF that all the parameters should match for OSPF neighborship, right? If we change these any of these values, the neighborship will break. So let's try to change the hello interval. What should be the hello interval? By default was 10. Let's make it 20. And show IP OSP, show IP protocols, show IP OSPF interface brief, show IP OSPF database. We got the message that neighborship has broken, right? Because now OSPF hello timers are not matching. Now let's see the value of show IP OSPF interface fast 0/0 of the timers that we just changed. The we changed that hello timer from 10 to 20. Okay, so that timer has changed automatically. So in EIGRP we manually change hello timer and hold timers, but here that timers also changing automatically if hello timers is changed, right? But we can also manually change that timer to a different value if we want. Now let's use same command on R2. Here neighborship has broken, okay, because hello and dead timers are different. So let's see show IP OSPF neighbors. We'll see that it is in a neighborship only with 3.3, not with 1.1, not with R1. Show IP OSPF neighbor. No neighborship, right? So what we'll have to do, let's change a neighborship hello interval on R2 also. Config T and go into interface fast Ethernet towards which we want to change the hello interval. So here we want to change IP hello interval. Okay, not hello inter IP OSPF. So we want to change hello interval. If we directly write hello interval after writing IP, right, it will by default it will change the prompt us to change a hello interval for EIGRP. But if we want to change a hello interval for OSPF, we have to give OSPF keyword. So after coming into OSPF, we can give hello interval of OSPF. Now we change OSPF to 20 on R1. So let's make it 20 on R2 also and show IP OSPF interface fast 0/0. Okay, so we see that here also dead interval change automatically to 20. Now the neighborship should be up. Show IP OSPF. It's taking time. Here we got the message that loading done to full. Now let's give the command again. Show IP OSPF. Now a neighborship is up, right? Show IP OSP PPF neighbor. Okay, so now again, once again, we have connectivity, end-to-end connectivity in the entire network. Now let's say uh, we want to do something with this cost also, right? So let's go to interface config T interface fast 0/0. We can change the cost also. So cost will be IP OSPF because all the commands we want for OSPF. So from here we can use this cost, interface cost. What will be the cost of interface, this F0 interface? So we can configure the cost from 1 to 65535. Currently the cost is, that is by default 10 for fast Ethernet, right? So let's make it 100. Let's make it 20. And right now let's check cost value once again. Earlier it was 10, now we have changed it to 20. Okay, and let me also show you that how we can change 0/0, how we can change the dead interval IP OSPF. Here we have a dead interval value. If we want, we can change that also to any value that we want, right? But let's not do it right now because we have already configured it with the help of hello interval. So guys, this was a short video about the basics of OSPF that we mostly use while configuring OSPF in our domain, right? If you like this video, please click the like button and comment below if you have any questions or doubt. Thank you for watching this video.